A very typical application of molarity problems is trying to find out the concentration of an unknown solution. And so the problem that we see here is very typical because it mixes stoichiometry and concentration in a way that you will see over and over again in many other problems. So at this point you may even want to pause the video and make sure you read through the question and before I start solving it, because it has to make sense, otherwise you will just see me solving it without having you thinking about it. So feel free to pause now, otherwise I'll just solve it. Let's see what this is saying. You're given a water sample to analyze from a lake contaminated with lead. Okay, so let's say that we have, with some imagination, this is a lake. Okay, so these are some waters and some clouds, and here's the sun. Okay, and this is the lead that is contaminated. Okay, and we have taken a sample from it. There is a sample of that lake, and it says that it takes 18 milliliters of sodium chloride, that's not lead, okay, to exactly precipitate the lead ions from, hey, 88 milliliters of the water sample. So we have taken 88 milliliters of sample. Okay, now 88 milliliters, we have taken 88 milliliters of the lake sample, and it says that it takes 18 milliliters of 0.01 molar of sodium chloride to precipitate the lead. What does that mean? It means that according to this reaction, once you add 18 milliliters 0.0 molar sodium chloride, that reacts with this, and then you'll start seeing this. Okay, so in a way, what this is saying is giving you the number of moles from sodium chloride that are required to react with lead. Okay, so how can we solve this? First, let's try to figure out how many moles of sodium chloride there are in 18 milliliters of 0.01 molar of sodium chloride. This is a typical problem of titration that you will see in the second semester, but it's actually you will see it in the first semester too, but it's so important that you will see it over and over again. Let's see if we can get any information from here. We have used 18 milliliters of the solution of sodium chloride, so let's calculate how many moles is that. 18 milliliters, I know that in 1,000 milliliters there is 1 liter, and I know that in 1 liter I have 0.01 moles of sodium chloride. Now I know the moles of sodium chloride. Let's call this quantity A. A is the moles of sodium chloride necessary to react with the unknown amount of lead that we have. We want to know the concentration of lead. Okay, well, according to the reaction, the stoichiometry tells me that for 2 moles of sodium chloride, it reacts with 1 mole of lead. This means, I'm going to call it B, this is moles of lead in 88 milliliters of the sample. So I'm very close now, because 88 milliliters, hopefully everyone can realize that this is 0.088 liters. The concentration of lead is the moles of lead that I calculated here over the liters. Therefore, we have calculated the unknown concentration of lead in the lake by indirectly making it react with a solution that we know its concentration. A very typical problem. It's important that you go through it stepwise and make sure you understand it.